Well, continuing with the strengthening by two phases aggregate. So how to strengthen the two phase when it gets aggregate, that is containing phase particle is the size of the grain is 1 point. Another is dispersed two phase structure in each particle surrounded by matrix orientation. In the dispersed hardening, the hard second phase material are mixed with the powder form of the matrix material, consolidated and processed by powder metallurgy technique. So the powder metallurgy technique, we see that all the materials are converted into powder, so that you are going to get a good fine powder. So when we do the casting, overall bonding, it is good because of the material uniformity. So this is the hard phase material we are going to mix. In the second phase, some materials which doesn't have solubility at high temperature as well as low temperature, so that it doesn't have any atomic matching between the lattice of the precipitate and the matrix used in material that must display high thermal stability. Alloys in this category are resistant to recrystallization and grain growth compared to single phase alloy. So here it shows the aggregated structure and the dispersed structure. So how to strengthen the fine particles? So precipitation hardening or edge hardening is the process by which you are going to go with the heat treatment and quenching the alloy. Further, it is provided with elevated temperature and also precipitates upon quenching and aging at lower temperature. The second phase must be soluble at elevated temperatures, so there is no atomic matching between the lattice, between the precipitate and the matrix. Precipitates formed obstruct the movement of the dislocation. Strengthening due to point defects, it happens. So there, point defects happens, vacancies are produced during hardening and interstitial defects. So number of vacancies in the metal increases when the temperature is increased due to non-uniform wetting and transferring it from a lower energy level to higher energy level. Equal number of vacancies and the equal number of vacancies, the number of quantity of the material, it is measured in terms of cubic meter, depends on an increase of temperature according to the equation. Nu is equal to n exponential of q v by kT. So like this, some of the constant values are expressed. If you substitute in the equation, you'll be able to calculate. So martensitic strengthening here, martensite transformation carbon steel increases by strength, producing strong barrier for dislocation motions. So martensite is obtained by fast cooling from the austenite phase in steels. So here, if you do fast cooling, diffusionless shear type transformations happen during quenching of steels. So further types of heat treatments, if you carry out like annealing, anodizing, if you do annealing, what we can do is, so here by doing annealing, homogenization and recrystallization and relief of residual stresses happens in the cold water related components. So electrical conductivity, if we take, so full annealed or processed annealed requires very slow cooling rate in order to form cores per light. In the process of annealing, cooling rate may be faster up to and including normalizing. So the main goal of processing with annealing process is to produce uniform microstructure. Partial annealing, full annealing and final annealing are the three stages of annealing where we can do. Not all annealing techniques involve recrystallization and stress relieving.